In deterministic causality, we typically use what are called sufficient component cause models. In the previous examples we've talked about so far, where we talked about necessary versus sufficient causes, we really talked about just one single risk factor and it's the type of causal relationship it has with a given outcome. However, in epidemiology and public health, we're often looking at multiple risk factors for the development of disease. So in deterministic causality, we use these sufficient component cause models. They're also called causal pie models because they look like a pie. These models employ both necessary and sufficient causes. And the model is constituted from a group of component causes that are diagrammed as a pie. So each one of these slices, basically, that are displayed in these different colors, each one of those is called a component cause. In these models, one of the components is a necessary cause. Together, the entire model makes up a sufficient cause complex or model. So in this example in the slide, we are talking about the development of tuberculosis or a tuberculosis infection. And so what we've done with this model is we have built basically all of these different factors that we think all come together. And if they are all present, everything in this pie, all of those slices are present, what we're saying is that it's a sufficient component cause model. That whole pizza or that pie, if all of those slices are there, it is sufficient to cause the outcome. So if exposure to TB, poor nutrition, poor ventilation, absence of a vaccine and crowding, if all of these things are here, then a tuberculosis infection is going to happen. So all of these slices, if they are all there, then the outcome is going to happen. If all of these factors or conditions are present, then it is sufficient to produce tuberculosis. Tuberculosis will happen. On the flip side, if I take away one of these slices, for example, let's say I take away poor nutrition and I just have the remaining conditions there, it's no longer sufficient. So tuberculosis is not going to happen if I remove one of these factors. The whole idea is that it's a sufficient component cause model if all of these factors are here together. If they are all here, then the outcome is going to happen. The other important thing to note is that these individual components, while all of them together are sufficient, there is always going to be one necessary component. Now, there can be more than one sufficient cause complex or model that we can create for a particular disease. So in this slide here, we have a perfect example of that. We're looking at tuberculosis as the outcome or the disease. And in this given example, we have built two sufficient cause models for the development of tuberculosis. You can see I have one model over here on this left side, and I have another model on the right side. Now, given that I have two models, in each one of these models, I have on the left side, I have three component causes, and in the right side of the slide, I have four component causes. I would expect that in order for tuberculosis to happen in each one of these models, all of those pieces, those components have to be present in order for tuberculosis to happen. What's also important to note is that there is one necessary cause in these models, meaning there's one factor that has to be there in order for the event to even potentially occur. And so given tuberculosis, we have to actually be exposed to TB in order for us to even develop a tuberculosis infection. So if you look at these models, I know that the necessary component is this exposure to TB. And the reason that I know that is because it's in both of these models. I could develop maybe 10 models for the development of tuberculosis and have 10 different pies. And in each one of these pies, I would know the necessary causes exposure to TB because that particular component would show up in every single model. And that's because it's necessary. It has to be there for the outcome to happen. So just a recap of these models, again, each one of these slices in here are the component causes. The entire model, so for example, this image here on the left, the entire model is sufficient because it's a minimum set of conditions that if they're present, they will produce the outcome. So if AIDS, poor nutrition, and exposure to TB are present, then what we're saying is that tuberculosis will happen. You're going to get that infection. It's going to happen. If I look at my other model, what I could say is that if crowding, absence of a vaccine, poor ventilation, and exposure to TB are all present, given all of these conditions are there and they are met, then tuberculosis is going to happen. They are sufficient. And as we talked about, you can have multiple of these causal pie, these models that you can build for a given outcome or a disease. And a disease may have more than one sufficient cause. So again, you can have multiple of these pies that exist that will inevitably produce the outcome. A really important thing to note is that in any model, if I remove one of those slices, that makes it no longer sufficient. So if I remove, for example, on this left pie here, poor nutrition, now I have made this this model, it's no longer sufficient. So if I just have the presence of AIDS and exposure to TB under this model, it's no longer sufficient and I will not get tuberculosis. All of those components have to be there in order for it to be sufficient and produce the outcome.